de aprendizaje e intercambio de conocimientos en esta industria en constante evolución. Durante esta jornada, tendremos el privilegio de escuchar a destacados expertos acerca de todos aquellos temas que nos competen e interesan a nosotros. Esperamos que aprovechen al máximo esta oportunidad para ampliar sus horizontes y para que, como Sarah Williams lo ha expresado muy bien, nos atrevemos a hacer cosas nuevas, porque nosotros hemos amado a las estrellas como para poder tener miedo de la oscuridad. Entonces, bueno, empezamos con nuestra primera conferencia, presidida por Tatsuhito Fujita. We will start with the master conference entitled Deployment Service for CubeSat from ISS, which will be taught by Tatsuhito Fujita. Before I begin, I will briefly read his trajectory. Tatsuhito Fujita is working in GEM Utilization Center of Human Spaceflight Technology Directory of JAXA. He's in charge of deployment service of a small satellite from the International Space Station. He has studied small satellites, space solar power systems, and so on in JAXA. He received a BE in Mechanical Engineering in Keio University in 1992. He graduated with a Master of Space Study of International Space University in 2001. With great pleasure, we present Tatsuhito Fujita.
Thank you very much. Hello, everyone. Can you hear my voice?
Yes, we can.
Okay. My name is Tatsuhito Fujita from JAXA, and I am an engineer for JSOD team. I'm sorry that I don't participate in this Mexican Aerospace Forum directly, but I'm very glad that I can lecture even online. Okay, so I can share my presentation now. Can you see my presentation now?
Yes, we can.
Okay. So today I'm going to talk to you about development service for CubeSat from ISS. Before I talk to you about development service for CubeSat, I would talk to you about history of space development in Japan simply at first. After World War II, many astronautical engineers in Japan lost their jobs as aircraft development was banned. Under the US occupation of Japan, this changed following the San Francisco Peace Treaty in 1951, which once again allowed the development of aviation technology. Following this, Professor Hideo Itokawa of Tokyo University established an aviation research group at the Institute of Industrial Science at the university. That group succeeded in horizontally launching the pencil rocket in 1955 in Tokyo. The rocket was 23 centimeters long and a diameter of 1.8 centimeters, very small rocket. But this is the first step of space development in Japan. After that rocket, which this research group developed, began flight further. In the 1960s, Japanese space research and development was primarily focused on satellite delivery system. In 1964, at the urging of Hideo Itokawa, the University of Tokyo established the Institute of Space and Astronautical Science, we call ISS. The first successful Japanese satellite launch occurred in 1970 with the launch of the Osumi by an L4S rocket number 5. So satellite was named Osumi, okay? So Japan is the fourth country which launched a satellite successfully in the world. In 1969, a National Space Development Agency, we call NASA, was established. so which was a separate agency from ISS. At first, NASA tried to use technology of United States toward developing bigger rockets and larger satellites. NASA launched N1 rocket in 1975 successfully. NASA developed a bigger rocket of N2 rocket and H1 rocket, and tried to use more domestic technology in these rockets. Finally, NASA developed the H2 rocket, whose all technology are domestic, and launched the H2 rocket in 1994. After that, NASA developed the H2A rocket, whose cost is lower, and H2B rocket, which delivers HTV of transfer vehicle for International Space Station. Today, H2A rocket was launched successfully 46 times. NASA developed a big satellite more than 2,000 kilograms of geostationary orbit and more than 4,000 kilograms on low Earth orbit. WINS, Japanese called Kizuna, is telecommunication satellite on geostationary orbit. This satellite was launched in 2008 using H2A rocket. Satellite weight is about 2,700 kilograms. ALOS, Japanese called Daiichi, is Earth observation satellite, which has a SAR, synthetic aperture radar, on low Earth orbit. Weight is 4,000 kilograms. This satellite was launched in 2006 using H2A rocket. Next, I introduced JAXA. Japanese Aerospace Exploration Agency, JAXA, was born in 2003 through the merger of three institutions, ISS, NASA, and the National Aerospace Laboratory of Japan, NAL. It was designated as a core performance agency to support the Japanese government's overall aerospace development and utilization. JAXA, therefore, can conduct integrated operations from basic research and development to utilization. Next, I introduce International Space Station. International Space Station, ISS, is a huge manned construction located about 400 kilometers above the Earth, and it is circles around the Earth at the speed of 90 minutes per orbit. This ISS project aims at improving science and technology to enhance life and industries on the ground. 15 countries are participating in the ISS project, including NASA, Russia, ESA, Canada, and Japan. So Japan has completed its human space facility, the Japanese experiment module Kibo, and trained astronauts who will operate its ISS Kibo at JAXA. Kibo has a pressurized module and exposed facility. So a variety of missions can be conducted both inside and outside Kibo. At the Kibo exposed facility, there are a lot of unique systems. It has an airlocks that allows payload to be moved from inside to outside the Kibo. Okay, and the small robotics arm, it's called a remote manipulator system. So many missions can be operated at the Kibo exposed facility. One of them is JAM Small Satellite Orbit Deployer. It's called JSOD. JAXA developed this unique system to deploy the satellite and inject the orbit from Kibo. This table shows a specification of JSOD. The satellite site is defined as a unit. One U is a cubic of 10 centimeter cubic. The JSOD can be released up to a 6U satellite, and 50 class satellites can also be released. Even though one size of a satellite is limited in Kibo cube. The ISS is moving in the direction of the x-axis, and the satellite will be developed the 45-degree backwards for the direction in which the ISS is moving. The maximum development velocity is 1.7 meter per sec, and the speed changes depending on the mass of the satellite. For the development mechanism of JSOD, there is a big spring inside the JSOD case, and then separation mechanism set on the outside of the case. As the satellite is loaded, the big spring is compressing, and the satellites are kept in the case by door. When the separation mechanism receives the command for release from the ground, the separation mechanism moves and the door is opened. Finally, satellites in the case are pushed by the springs deployed. There are two types of cases that can carry a satellite the size of CubeSat. In the JSOD case, the satellite is set to the case on the ground, and the maximum size is 3U in the slot. While in the JSOD-R case, the satellite is loaded into the launch case and transported to the ISS, where it is stored in the keyboard module. In the keyboard module, the satellite will be transferred to the deployment case by astronauts. So the JSOD-R can be used repeatedly and can release max 6U satellites in the slot. In addition, although not shown here, there are a special case for the wide 6U size and 50 kg class. Next, I explain how the developed satellite will be transported to space and deployed. First, the deployed CubeSat is installed a JSOD case, and then packed in the cargo transfer bag. Then they are transported to NASA and launched as pressurized cargo by rocket. Because of CTB bag, the vibration environment is lower than that of a rocket. After a JSOD case arrived on the ISS, like this movie, astronaut mount the JSOD case on the platform. Okay. So now crew is mounted, and then the platform is carried out of the ISS through the airlock like this, and then robot arm carries it to be the deployment position, and the satellite will be deployed like this. Okay. So operator is check. Okay. So another okay. So this movie shows another deployment of satellite. This is Wakata astronaut. He tried to deploy the Vietnam and the NASA satellite. In this movie, so Brazil satellite is deployed. So now the member of Brazil team come to Tsukuba Space Center in deployment of satellite. Okay. This is a Yui astronaut. This is a Japanese satellite deployment. Okay. So, okay, next movie is the deployment of 50 kilogram satellite in Philippines. Okay. So, if we want to see the deployment of satellite, you can go to Tsukuba Space Center. Okay. So next, the operation command to move the robot arm and to deploy the satellite are sent from the ground. Our front control team and engineering team are in perfect condition and support deployment from the ground. The size of the satellite is small, but the mission is made possible by many support members. In this slide, I would like to introduce a few advantages of small satellites compared to large ones. Small satellites are attracting considerable attention because of their short time and low-cost development. They are suitable for first-time users and as the first step toward developing a large satellite to solve social problems. Since the development cost is low, small satellites can be used as educational tools and challenging missions. And then small satellites can be developed in about 1 to 2 years, and above 1 year of operation is expected. Therefore, even college students can experience the whole process of satellite development and operation. And users can get quick return on your business investment, technology demonstration, and so on. In addition, practical remote sensing data can be obtained from the small satellite. It means that sufficient data can be obtained even with low cost and short-term development, which is a great advantage in terms of cost effective. I introduced achievement of JSOD. The JSOD operation started in 2012. And this year marks the 11th year. JAXA have continued to provide development opportunities, so 74 satellites from 31 countries have been successfully deployed from the JSOD until now. As you can look at the world map, we are releasing satellites from all over the world, regardless of region. Also, 5 of the satellites are selected by CubeSat have been successfully deployed so far. If Guziba-1 is deployed from JSOD, Mexipath is colored. Next, I introduce capacity building through JSOD. JAXA has opportunities of satellite deployment to various countries as a gateway for sharing the values of ISS keyboard for the purpose of enhancing satellite development and operation technology. JAXA launched new comprehensive capacity building measures to provide the education programs and sustainable satellite development opportunities, which finally contribute to the SDGs goal 4, 8, and 9. CubeCube and CubeCube Academy program in collaboration with the UN-USA. Mori-san of UN-USA introduced these programs after my presentation. I introduced JCube program. JAXA launched the new fee-based satellite developed initiative, which is called JCube from 2021. In this JCube, JAXA allocated up to 6 satellite development opportunities for 1U to 3U satellites a year. JAXA provides 2 sets of frameworks, international collaborative frameworks and innovative mission framework. JAXA signed the agreement of JCube with UNICEF Japan in April 2021. You can find the outline of JCube of the following website, this one, okay? So in the case of international collaboration proposal, at first, user of satellite use matching system for potential international partners of Japanese university. If a partner is decided, they apply this proposal to JCube office. If documentary examination and interview examination are passed, JAXA checks this proposal. Winner of JCube is selected after check of JAXA. So I recommend that users apply JCube after a CubeCube program is experienced. This table shows winner of JCube program. 8 teams were selected and satellite of one team satellite was deployed in July this year. In international collaboration proposal, teams of Philippines, Thailand, Mexico, Sri Lanka, and Malaysia was selected. Mexico team is a National Autonomous University of Mexico in collaboration with Kyushu Institute of Technology. Okay. So we are hoping that GUJIBA-1 is developed smoothly and operated successfully after the deployment from JSOD. JAXA is looking forward to supporting your challenge. Finally, I would like to show you the movie of JSOD for introduction. Okay, just a moment. Just a moment.
Thank you very much.
I try to start the movie now.
Yes, of course.
Okay. Okay. Can you see movie?
Yes.
Okay.
JAXA's GEM, Small Satellite Orbital Deployer, JSOD. The Japanese experiment module, Kibo, on the ISS. This project is conducted by JAXA, utilizing Kibo's distinct function of having both an airlock and a robotic arm. JAXA has provided many opportunities to universities, space emerging nations, private companies to deploy satellites. A standard 1-unit microsatellite, CubeSat, is 10 centimeters square in size. JSOD can meet various needs by accommodating 1 unit to wide 6-unit CubeSats and up to a 50-kilogram sized microsat. It is possible to load up to 12 1-unit satellites at the same time. In addition, to meet increasing demand, JAXA has developed a new deployment case, JSOD-R. JSOD-R can be used repeatedly and can release up to 6-unit satellites in a slot. Satellites are deployed using a powerful spring attached on JSOD cases. Satellites are launched into low Earth orbit for approximately 1 year. Let's see how satellites are transported to space and launched into orbit. User satellites are handed over to JAXA and carefully installed in a case. The case is wrapped with cushioning material and stowed in the cargo transfer bag. Compared to conventional rocket-mounted launches, this method drastically mitigates launch vibration, which contributes to reducing satellite development cost. After the cargo transporter reaches the ISS, the crew receive the satellite cargo transfer bag and conduct JSOD setup on board Kibo. The JSOD case is installed on the airlock slide table. As for JSOD-R, astronauts will load the satellites in orbit. The case is transferred outboard using Kibo's airlock and robotic arm, a unique dual function possessed only by Kibo. The Kibo Mission Control Room on ground conducts this operation. Developers and participants gathered at the Tsukuba Space Center watch in anticipation as the robotic arm is set to the releasing point.
10, 9,
A command is sent from the ground. Release. Since 2012, JAXA has been providing deployment opportunities to universities, private companies, many domestic and foreign users who do not have the capacity to do so. In addition, JAXA is cooperating with the United Nations Office for Outer Space Affairs and University Space Engineering Consortium to enhance social and international contribution. The world is entering a next space age, and the number of JSOD users is steadily increasing. Creative user ideas can extend the possibilities and value of low Earth orbit utilization, and JAXA continuously supports the pursuit of new possibilities. Now, the next satellite deployment from Kibo could be yours. Good luck.
Okay. So my presentation is finished. Okay. Thank you very much.
Thank you very much, Mr. Tatsuhito. Before we end this presentation, I would like to start a space for questions and answers, if that's okay. So if anybody has a question, you may raise your hand. Okay.
Good morning. I have a question on behalf of a lot of aerospace students here at UPAE. And the main question is, how could they become more involved in working more directly with JAXA? Like, is there like some sort of like internship, or what is the proper bureaucracy or paperwork for them to accomplish that?
Sorry, I can catch. Sorry, I'm not good at the hearing. So please repeat your question. Okay, simply.
Yeah, I apologize. So on behalf of a lot of aerospace students, the question was, how can they be involved or work more directly with JAXA? Like, is there like some sort of internships, or what is the process for them to become fully involved in working with JAXA?
Sorry. So JAXA don't involve many internship for foreign countries student.
Okay.
So yeah, usually I recommend the some university like the Kyushu Institute of Technology. This university gather the internship student from all over the world. So maybe the developing country. I recommend this internship system. Okay?
Okay. So, thank you so much.
You're welcome.
We will proceed with our next question.
Hi, Tatsuhito Sensei. Thank you so much for your presentation. My question is, since the Kibo uses the ISS to provide the service, how many years are this service expected to continue? For example, I've heard that the ISS is kind of planned to stop its contributions for some years in the future, but this could mean Kibo would also stop Are there any plans to continue even after the ISS, or is the ISS still going to work for many years to come?
So now, in this present plan, ISS will be operated until 2030. So this JSOT, now JAXA have a plan that the JSOT program, JSOT will be used until the end of operation of ISS. Okay. So after you mean the does JAXA do after the end of operation of ISS? Okay. Okay. So maybe now JAXA don't have a plan of operation of sorry. So now JAXA don't have plan of after the end of operation of ISS now. So now JAXA is thinking of the plan after after the end of ISS now. Okay. You are welcome.
Yeah, he says thank you. Hello, and thank you for your presentation. My name is Gerardo, and I have a question here. How often do you launch satellites? I mean, is it possible to launch like a constellations of thousands of satellites with JAXA and Kivo?
So you mean how often is there 1 year? 1 year the how often the satellite is deployed? You mean 1 year? Sorry.
I mean, if I plan to launch a constellation of thousands of satellites, how much time will it require with you to launch them?
Thousands of satellite constellation. I think it's difficult to deploy the thousands of satellites using JSOT because now maximum of satellite which are deployed using JSOT is maximum is 24 satellite of one satellite of one size. So now, so 1 year, usually 3 or 4 times of deployment using JSOT. So yeah, at the maybe the maximum of satellite which is deployed, which are deployed about 100 satellites of one unit, not so many. So now JAXA don't think the constellation of satellite is now. Okay?
Okay, thank you.
You are welcome.
I have a question. The launch profile of this CubeSat is, as you said, 45 degrees from a deer of the ISS. This evidently reduces a lot the lifespan of this CubeSat, these little satellites, because obviously they are pointing toward the Earth. For my limited knowledge, I think this is for security from the ISS itself, so orbits don't overlap. So my question goes to if there is, with this technology that you have on the ISS, is it possible to launch these CubeSats not pointing toward the Earth, but pointing upward, so to increase the lifespan of these satellites and the missions, or we will rather prefer to launch these little satellites to our rockets?
Okay. So of course, the orbit of satellite, which is deployed from JSOT, is almost the same of the ISS orbit. So if satellites don't have the propulsion system, usually the satellite, altitude of satellite is lower and lower. So lifetime is about half year or the 1 year at longest, not so far. So if you want to make the lifetime of satellite longer, so satellite need have the propulsion system. So for keeping orbit, but it's difficult to develop the propulsion system for CubeSat because very small propulsion is needed. Okay. So now usually the satellite, most of satellite from JSOT is without propulsion. So maybe the lifetime of satellite is about half a year or longest 1 year now. Okay.
Okay, thank you.
Anybody else got a question? Yes?
Well, hi. First of all, good morning. Well, I have a question related with JSOT system. That is, how this system will work in the future. For example, in deep space exploration, like with telescopes and like similar to James Webb or Hubble.
You mean the JSOT system can be used for deep space mission? You mean? Sorry.
Yeah, like with more distance and maybe outside of the solar system, for example.
So of course I said the JSOT, the satellite from JSOT is on orbit of low Earth orbit. So maybe if you try to if you realize the deep space mission, maybe so you need to use another transportation system. So who can go to deep space orbit? Okay. So the JSON cannot be used for the deep space mission now. Okay.
Okay, thank you so very much.
Hi, I have a question.
Yeah.
I've heard that JAXA have collaborations with an important university from Mexico, which is the UNAM. My question is, does JAXA still have contact with like institutions, like universities, after the module drops the satellites, like for help these institutions, or after the development, the institution is fully responsible of its satellite?
Sorry, I'm sorry, I can catch. So please simply your question. Okay.
Oh, okay. My question was that if JAXA still have contact with institutions like universities after the module drops the satellite, like for help the institution to successful mission. Yep.
So you mean the JAXA is JAXA collaboration with the some University of Mexico?
Yeah, I've seen in your presentation that JAXA is collaborating with a university. from here.
Sorry. Okay. So I showed the JCube program. So in JCube program, Mexico, the National Autonomous University of Mexico is selected. So at the time, so maybe so this Mexico University is in collaboration with Kyushu Institute of Technology at first. So Kyushu Institute of Technology and the Mexico University is collaborate and the joint project team. So JAXA don't collaborate. JAXA don't in collaboration with Mexico team directly now. So at first, so in JQ program, so maybe your university try to apply. So before applied application of JCube, so you need be collaboration with Japanese university at first, okay? After that, so you try to apply JCube. It's okay?
Yeah, it's okay. Thank you.
Does anybody else got a question? Yes. We will have two more before we conclude.
Hi, thanks. Well, my question is, what sets JAXA apart from other space programs?
Sorry, you said JAXA?
Yes, what sets JAXA apart from other space programs?
Apart from modern space program? Sorry,
Yes.
I'm sorry. I can get apart from
Other space programs.
outer space program,
Other space programs.
other space program.
藤田さん、JAXA が他の宇宙機関と比べてどう違うか、何が JAXA が一番優れてるか、JAXA が他の宇宙機関に比べてどういいかっていう点を。
Okay, sorry. I think JAXA. I think JAXA. The JAXA. The space development of JAXA is very various. So of course the JAXA in relation to the ISS and the JAXA developed the launch vehicle, a big rocket, and the JAXA make the JAXA developed the big satellite like the Earth observation or the telecommunication, and the JAXA JAXA developed the deep space of satellite like Hayabusa. Okay, so I think the good point of JAXA is various space development. So the development of JAXA is very, very various. Okay.
Yes, thanks a lot. Appreciate it.
So you're welcome. Sorry.
Okay, so this is our last question.
Dear Mr. Tatsuhito, I am Eugenio Ruti. I am part of the team, general director of the Shiba One team.
Thank you very much.
I would like really appreciate, thank you for being in this meeting, but not only for that. but also for your support during our work with you. And I'm telling this in front of this audience of students at UPAEP, but also from another universities in Mexico. Thank you very much, and we are very, very happy to work with you. Thank you very much.
Oh, thank you very much. Yeah.
Thank you very much. It's been a pleasure having you here, even if it's online. It's really been a great pleasure. We hope to grow this friendship between you and UPAEP in order to create new projects. So, well, this is how we conclude our first presentation. But first, I will ask you to give Mr. Tatsuhito a round of applause, please.
Thank you very much. Yeah.
Thank you very much. Bueno, tendremos una breve preparación de 5 minutos para nuestra presentación con Hazuki Mori. Así que por favor no se muevan de sus asientos que comenzaremos en breve.